Okay, these first two problems from problem 5, A and B, 5A and 5B, are similar to problem 4, except both of them are three things added and subtracted. Problem 4 only had two things added or subtracted for each one of those, and that's the main difference between these two, 5A and B, and all the problems from problem 4. That's the main difference. But also, at least with this one, we're going to do one more thing before we combine. We're going to basically do this the same as problem 4, even though there's three things. Whether there's 2 or 3 or 4 things doesn't matter. If there's 2 or 3 or 4 logs added or subtracted together, same, doesn't matter. The only thing that does matter is we can't have, before we combine it, we can't have a log multiplied by something. So like in this case, this last log is multiplied by 4, and so just before we combine it all into one log, it means that we have to make this 4, bring it into the log and make it the exponent of y, and we can always do that. Just like we can take, if there's an exponent, this exponent we could bring out to the front here, but also we could do the reverse. If there's something out in front, we can make it the exponent. Okay, so we're going to do that as a first step. Okay, so this first log stays exactly the same, log x squared. Next log stays exactly the same, log xy. And then this log, the 4, is going to get put as the exponent of y, so it will become log of y to the 4th. Okay, now that none of these logs have anything multiplied by them out front, now we can combine it all into one log. There's no base written on any of them, so that means they're all base 10, so they basically all have the same base, right? If there's no base actually written, it's implied that the base is 10. Okay, but anyways, they're all the same base, and that's the important thing. Okay, we have one log that's subtracted. One of the logs is subtracted. That means when we combine this, we're going to have a log. That means we're going to have a log of a fraction. Okay. The first and last logs are both positive because there's no negative out in front of this first log, and then this is added. There's a plus in front of this, in front of the last log. So the fact that those first two are positive log, the first and last are positive logs, then those two arguments, the arguments of those two logs, will go on the top of this fraction. So this x squared and this y to the 4th both come from positive logs, so they'll both go on the top of this fraction. Okay, and then this, if we look at the log here, the middle log is subtracted. That means its argument is going to go on the bottom of this fraction. So this xy comes from a log that's subtracted, so that xy goes on the bottom. Okay, and again, we could simplify this more, but we're going to not focus on that right now and just leave it like that. Okay, this one's actually, we can do in one step. We notice first that none of these logs have anything multiplied out front. There's nothing out front here. There's no number out front here, and no number out front here. Okay, so we don't have to do the first step that we did in the last one, where we bring it into, make it an exponent, bring it inside and make it an exponent. Okay, so we just go right to the answer. So first of all of these are ln's, which means log base e. Okay, so we just know most important thing is that they all have the same base, which means we can combine them. If they had different bases, then we couldn't combine them. But for a quiz like this, they'll all have the same base every time. Okay, so they all have the same base. They're all ln, so we'll have an ln. One of them is subtracted, so we'll have a fraction. Okay, and then just like the last one, the first, well, at least in this one, there's two positive logs. The first and second one are positive. So there's, this is positive, and since there's no negative out front, and then this is adding, so that's positive. And so the two logs, the two arguments that come from those logs, this argument and that argument, get put on top of this fraction. So that gets put here, and then also this gets put on the top, just kind of multiplied everything. Okay, and then the argument of the log that's subtracted, that last log, if we look at that argument there, that gets put on the bottom since it comes from a log that's being subtracted or a log that's negative. So that argument, 16x to the half, goes on the bottom, and that's the final answer. Okay, so this log, the only rule we can use is the rule if you have a log of two things multiplied. And that's what we have now. We have log of 6 times 11, and so that rule says if you have a log of two things multiplied, you can split it up into the two logs that are added, and then each thing here, that 6 can go there, and then this 11 will go in the other one. And that's all we can do for this one, so that would be the final answer. Okay, this one's the same as the last one. We have a log of two things multiplied, so we'll split it up into two logs that are being added. That 5 goes in the first one, and that 3 goes in the second one. And that's it. Okay, so this one, the whole inside of this log is raised to the 5th power. There's 6/11ths. There's a fraction, but that fraction's in parentheses, and so that whole, and it's raised to the 5th power. So that whole fraction is being raised to the 5th. Okay, so that means that we're going to use, when that happens, we'll use the power rule first. So the power rule says that we can, whatever the exponent is of the argument, we can take it out and multiply it out front. And so that's what we'll do first. So actually, let me rewrite this. Okay, so the big thing is we'll take this exponent and just rewrite it out front. Kind of take it away and rewrite it out front. And if we do that, that becomes 5 times log of 6/11. Okay, so the only other thing we can do, that 5 will just kind of stay out outside, or just kind of, we'll just kind of carry that over every step at the beginning. So the log of 6/11, we have a log of two things subtracted, two things divided, so we can change it to 2 logs subtracted. And so this 5 will stay the same, and we'll use parentheses. And so, yeah, so the fact that we have a log of 2 things divided, we can change it to 2 logs subtracted. And then this, the top, whatever's in the top of the fraction goes in the first log, and whatever's in the bottom of the fraction, that 11, goes in the second log. And that's it. That's all we can do. So that'll be the final answer. Okay, so for this one, there's an exponent in there, 3 times 2 to the log of 3 times 2 to the third. So there's an exponent in the argument, but we can't pull it out yet because that exponent doesn't apply to the whole argument. It just applies to part of the argument. It just applies to this 2. So the fact that this 3 is not being raised to the exponent also means we can't use the power rule first. We can only use the power rule when everything's being raised to a certain exponent. But what we can do, so we have a log of two things multiplied. We have 3 multiplied by 2 to the third, and so we can use the product rule and split this up into 2 logs that are added together. Okay, so this first thing can go here, and the second thing being multiplied can go in the other one. Okay, this second log, now the whole argument, now the only thing in the argument is 2 to the third, and so now everything in the argument is being raised to an exponent, and so this exponent 3 can be pulled out and multiplied out front here. And so that's the only thing that we'll do to change this. So that first log 3 will stay the same, and then this 3 here, this exponent will come out front and get multiplied out front. So we'll have 3 times log 2. And that would be the final answer. Okay, kind of similar to the last one. We can't use the power rule first because this whole thing isn't being raised to the 4th power. Just this 2 is being raised to the 4th power. Okay, so this 5 isn't being raised to an exponent, so we can't use the power rule first. Only when everything's being raised to the same exponent. Okay, but what we can do, we have a fraction, so we can split it up into 2 logs subtracted. So anytime you're taking the log of a fraction, you can rewrite it as 1 log minus another log, and then the thing in the numerator goes in the first log, and the thing in the denominator goes in the second log. Okay, and then this first log, now the whole argument is being raised to the 4th power. It's 2 to the 4th, and so now this exponent we can pull out. So this 4 we can pull out and multiply it out front. And when we do that, we get 4 times log of 2. And then there's nothing we can do with this second thing, so we just leave it the same, minus log 5, and that's the final answer. Okay, so with this thing, the log, so this is log of 6/5 to the 6th power. So in this case, everything is being raised to the 6th power. This is in parentheses, and everything's being raised to the 6th power. So when everything in the log is raised to a certain exponent, we'll use power rule first. And so we will take whatever this exponent is here and multiply it out front. Okay, when we do that, we get 6 times log of 6/5. Okay, and then if we look at this log, it's log of 2 things divided. So anytime you have a log of a fraction, log of 2 things divided, you'll split it up into 2 logs subtracted. Okay, so this 6 just stays out front, and we'll need parentheses. And so we'll change it to 2 logs subtracted. And then the numerator of the fraction goes in with the first log, and the denominator goes with the second log, and that would be the final answer. Okay, so this next one, this has a fraction, but it also has an exponent. But this exponent doesn't apply to the whole fraction, just applies to the y in the denominator. So we won't do power rule first. We'll do the quotient rule first, where the fact that we have a fraction, we'll split it up into 2 fractions subtracted. So that's what we'll have to do first. So we'll write 2 logs subtracted. and then the top thing in the numerator of the fraction goes in the first log, and then the thing in the denominator of the fraction goes in the second log. Okay, and then now in this second log, the exponent 6 applies to everything. There's only a y in the argument of the second log, and so that means that since the 6 applies to everything, we can pull it out front. So this 6 in the next step we'll pull out front and have it multiplied by this second log. Okay, so this first one will stay the same, just log x minus, and then this 6 gets put out front, and then we'll multiply that by the log y, and so that'll be the final answer. Okay, so for this one, this exponent applies to everything, since these are in parentheses. It's the whole a times b that's being squared. So since the exponent applies to everything in the argument, we'll use the power rule first. And so that means we can take this exponent and bring it out front and multiply it by the log on the outside. Okay, so we'll rewrite this, the 2 that got multiplied out front to the log, and then we just have a times b left inside. Okay, and then now the fact that here we have a log of two things that are multiplied, we can split it up into two different logs that are added together. Okay, so this 2 just stays there. We'll have to have parentheses because we're going to be writing two things added. So we'll have these 2 logs that are being added. Okay, the first thing being multiplied here goes in the first log, and the next thing being multiplied goes in the second log, and that would be the final answer. Okay, here we have a log of two things divided. The only exponent in this problem only applies to the top, doesn't apply to everything. So we can't use the power rule first, which means we'll have to use the quotient rule first. So we'll split this log up, since we're taking log of a fraction. We'll split this up into 2 logs that are being subtracted. Okay, the thing at the top of the fraction will go in the first log, and the thing in the bottom will go in the second log. Okay, and then the next step, now this exponent applies to the whole argument, which is just u, and so that means we can use the power rule, and we can take this exponent and pull it out and multiply it on the outside. So that exponent 4 comes out, gets multiplied by the log u, and then that log v, just the minus log v, just stays like that. There's nothing we can do more, so that's the final answer. Okay, the only exponent in this problem only applies to the bottom, doesn't apply to everything, so we can't use power rule, which means but we do have a fraction, so we can use quotient rule. So we'll rewrite this as 2 logs subtracted. Okay, the top here, that log goes in the first one, and the bottom of the fraction in the original log will go in the second one. Okay, now this exponent applies to everything in this second log, so that means we can use the power rule and bring this out front. So this exponent will get multiplied out front, and when we do that, the first log stays the same, and now that 5 comes out front here, gets multiplied by the log, and just left with log y. So log x minus 5 log y, and that would be the final answer.